Alright class, this is your 6-2 notes. 6-2, we're starting the standard normal distribution. Standard normal distribution is a distribution where we have a bell curve with the mean, so it's centered around 0, and then the standard deviation is equal to 1. Alright, it's also called the Z distribution. That's why I have this Z highlighted down here, and that Z is the same Z from Z-scores that we've seen before. Alright, so it's bell-shaped, centered around 0, mean of 0, standard deviation of 1. Alright, it's also what we call a normal probability density function, or a density curve, and what that means is the complete area under the curve is equal to 1. Alright, so the entire area is equal to 1, and what that allows us to do is find probabilities. It's very similar to in the discrete section in chapter 5, the right hand column, the probability column adding to 1. Now the area underneath the curve has to be 1. Alright, the methods that we're going to use to find areas are the table A2. It's in the back of your book. I'll show you how to find that table. So here's our class's main page. If you click on chapter contents here and open that up, and then scroll down until you see the appendices down here at the bottom, click that, and then appendix A is tables. If you open that appendix A, it will open to these, and you see here what it was saying. Table A2 is the standard normal distribution. So if I start moving to the right until I get to table A2, there's the Z-scores, the Z distribution. Okay, now these things take you an area to the left. Alright, or they give you the Z-score, and then it gives you the area to the left of that Z-score. Alright, and then the calculator, the TI-83 or 84, the normal CDF feature. So it's under the second VARS menu, the distribution menu that we've seen before. So if I press second VARS for VARS, oops, I got to turn it on first. If I press second VARS for VARS, there's normal CDF right there, option number 2. So that's also what we're going to use to find these probabilities. Alright, we start with table A2. So it's designed for only the standard normal distribution. Okay, so we have to have a mean of 0 and standard deviation of 1 to use it. Okay, and again, it's on 2 pages in our book. We start with the negative Z-scores, and then we have a positive Z-scores. Alright, so this is the first page, the negative Z-scores, and then if you click next, there's the positive Z-scores on the next page. Alright, and this is the big thing. Each value in the body of the table. Alright, the left side gives you the first 2 place values, the whole number and the tenths, and then the up along the top is the last place value, the hundredths place. And once you find where they intersect, you're finding the area to the left of that thing. Alright, and that area is the probability. That's the new thing that we have to get down. Alright, so here's an example. Alright, they're giving you an area. They want you to find the area to the left of Z equals 1.27, or find the probability a Z-score is less than 1.27. Well, what I'm breaking down here is 1.27 is equal to 1.2 plus 0.07, and I did this on the calculator just so you can verify it. 1.2 plus 0.07 is 1.27, and the reason why I'm showing you that is the Z table is broken up into tenths place along the side and hundredths here. So here's 1.2, here's 0.07. Where do they intersect? They intersect at this number, 0.8980. So that means that the area to the left of 1.27 is 0.8980. Alright, so that's how we use it. We just find the first 2 places in the number, alright, and then we find the very last place, the hundredths place in the number, alright, and then we find where they intersect on the table, and that gives us the area to the left of that number. Alright, and then interpretation. How do we interpret that, what we just found? We say that the probability of randomly selected Z-score being below 1.27 is almost 90%, 89.8%, or 89.8% of Z-scores are lower than 1.27. That's another interpretation we could have. Alright, here's another example that has thermometers. So these thermometers are supposed to have an average reading of 0, a standard deviation of 1, just to make them standard normal. Alright, we'll get into better application later, where we're not kind of forcing an application. But anyway, if we're randomly selecting a thermometer, find the probability that it reads above negative 1.23 degrees. Okay, it's supposed to read 0 for the freezing temperature of water, but it's reading negative 1.23. So what's the probability of that? Well, I'm going to show you from the table. We get negative 1.23 is 0.1093. So that area to the left is 0.1093. For the right, we had to subtract the area to the left minus 1. So I'm doing 1 minus 0.1093 to get that 0.8907. Okay. Alright, and then the interpretation will be that 89.07% of thermometers have readings above that. Alright, now the toughest thing would be to find something between two values. Now we've just seen these two numbers. They were used in the last two examples, the negative 1.23 and then before that the 1.27. So we've seen the area to the left of these and to the right of this one. But when we have this and we're using the table, what we need to do is find the area to the left of the upper number and subtract the area to the left of the lower number. So this area we already found to be 0.8980 minus this area we found to be 0.1093, and then if we subtract those, 0.8980 minus 0.1093, we get 0.7877 or 7887 as our answer. Alright, so that's the area between those two values. And then just as a summary, this is how we do it. We find the probability z is less than the upper value. That's what we did right here. When we got the 0.8980, the probability we're less than this. Then you find the probability z is less than the lower value. Alright, that's when we got the 0.1093, the area to the left of this. And then we subtracted those two. Okay, and that's what we're doing right here. Alright, and that'll give you the probability that we're between those two scores. Alright, and then notational stuff. Probability A less than or equal to Z less than B. Sorry, I said less than or equal. Actually, it does not matter if these are underlined or not. If these are not underlined versus they are underlined, still the same thing. Because the probability of exactly one value in a continuous data set is 0. Alright, but anyway, that's the probability a z-score is between these two numbers. This is the probability the z-score is bigger than that number, and that's the probability the z-score is less than that number. Okay, this is what the table gives you. If you have a problem like this, you just look at the table and you write down the exact number. These two you have to do a little bit of modification. You have to subtract from one, and then you have to find the lower and upper and subtract for that one. Alright, flip side, the other way, going back the other way, you can be asked to find a z-score if you know an area. Alright, if I give you an area and you need to tell me the z-score, then we're using the table in the opposite direction. Alright, we're looking for this number in the table, and then that'll give us on the outside of the table the z-score that has that area to the left. So here's for this one. Alright, 1.64 and 1.65, if you average those two, 0.9495, 0.9505, if you average those two numbers together, 0.9495 plus 0.9505, and then divide by 2, you get 0.95. So that little star in your book refers to the average of these two numbers, 1.64 plus 1.65. If I average those two, I get 1.645. Alright, and that's what we use for that z-score. Okay, now it won't always average numbers. Sometimes we'll find the closest number to that and it'll be in the table. But if it's not, and if it's a perfect average like it was here, then that's when we average things. Okay, but if it had been, find the area or find the z-score with the area left of 0.9484, then we would have just picked off 1.63 and just use that exact number. But because these two average to 95% exactly, then we average those two z-scores. Alright, these are percentiles or percentages. When you see these things, finding the middle something something percent, like the middle 95%, the easiest thing to do is take that 95%, subtract it from 100, and that leaves you the area in the two tails. So if the middle 95% is subtracted from 100, it leaves us 5%. So that means 2.5% for the bottom, 2.5% for the top. Okay, and because of the symmetry at 0, these z-scores that cut off the middle 95% will be opposites. So see, I have a negative z and a positive z. Alright, they'll be the opposites of each other. Now this is the important one. Because the table gives areas to the left, we want the z-score with an area to the left. This z-score is an area to the right, so this one would be the easiest one to use. Alright, so I go in my table, I look for 0.025. Alright, there's 0250, and if I look, that's negative 1.96 where those two meet. So that's why I'm putting the negative 1.96 there. Alright, and then positive 1.96 up here. So the middle 95% of z-scores are between plus and minus, positive and negative 1.96. Okay, so when we are told to do that, finding the middle such and such percent of z-scores, this is the steps that we take. Subtract p from 100, whatever that percentage is, convert that to a decimal, so 95 minus from subtracted from 100 is 5, convert it to a decimal is 0.05, divide that by 2, 0.025, because we're doing half areas to each tail, and then find the z-score that corresponds to the area from step 3 for the lower z-score. Alright, that's exactly what we did right here. Alright, we divided that 0.05 in 2, we found the 0.025 in the table, right, and then we just took the opposite for the upper number. Alright, and that's exactly what we could do again. If I wanted to find the middle 50%, alright, that'd be like Q1 and Q3. I'm looking for 0.25 in the table. So this is the positive z-scores. Let me move back. I'm looking for 0.25, the closest I can get to 0.25 in this table. If I look right here, let's see, 0.2514, right, 0.2483. These two are the closest that we get. If I take these two numbers and average them, right, 0.2514, 0.2483, I get 0.24985, really close to 0.225. So I would average then the two numbers that correspond to this, which would be negative 0.67 and 8. So negative 0.67 plus negative 0.68, oops, negative 0.67 plus negative 0.68 divided by 2, and it always just puts another number after that one. So negative 0.75. Alright, and then that's the numbers that I'm putting in here. Okay, and that means Q1 and Q3. Alright, so that's the z-score that corresponds to negative 0.67. That's the one that corresponds to negative 0.68. I average those, I got this. So that means, I'm pretty close. So these two numbers will cut off approximately 50% in the middle of them, in between them. Alright, now, moving away from the table into your calculator. Okay, calculator helps so much with this. So much. There's two different features on your calculator. They're going to make all that stuff that we do on the with the tables kind of obsolete, in my opinion. Alright, so if I want to find, this is the first problem we did, find the probability z-score is less than 1.27, I press second vars, I highlight normal CDF. Now, the way this works, you have to put, for normal CDF, you have to put in lower number, upper number, lower number, upper number. So if, like for this one, when there is no lower number given, it's just everything to the left of this number, then we just make up a really big lower number. So I use negative 999. Right? If you ever wonder if you have too few nines, then go back and add another one. Right? You can't have too few. You can have too. You can't have too many. You can have too few. But if you're ever wondering if you don't have enough, just put more. Um, it just has to be several standard deviations away from the mean, like 5 or more standard deviations away from the mean, and you'll get the right number. Okay, and then I put in 1.27 as the upper number, okay, because it has to have a lower and an upper. Close that off, hit enter. So there's our number, 0.897957. That would round to 0.8980. Alright, notice also that if I would have selected negative 5, 1.27, alright, that's still giving us roughly the same thing, especially to the first 4 decimal places. Again, it just has to be farther away from the mean than 5. Even if you use like negative 5 or negative 10 here, it'd be fine. But because we're going to change things later, go ahead and get in the habit of using the nines, a bunch of nines. Alright, and same thing, the problem where I'm finding the probability z is less or greater than 1.23, I don't have to do 1 minus or anything. I just plug in the lower number as negative 1.23. The upper number now is positive 99999 because we're going up to the right tail. Alright, what you can think of these two numbers as that go in your normal CDF are, where does this shading start? It starts at negative 1.23. Where does it end? It doesn't end, so we just put 99999. Alright, on the other one, where does the shading start? It starts at negative 99999. Where does the shading end? It ends at 1.27. Okay, so if you think of it that way, it makes it easier to plug in the number. And get in the habit of sketching a bell curve every time you do a problem like this. I do. Every time I do one, I sketch a bell curve. Alright, and then the one we saw before, probability of z-score is between these two that we found with our tables. I just press normal CDF. I type in the lower number, negative 1.23, comma, the upper number, 1.27, enter, and there's our answer, 0.7886. Okay, so it's very easy to use that calculator to find these probabilities. You just have to have a little sketch, an idea of what it is that you need. Alright, so here's some more examples with the calculator. The probability of z-score lies between these two numbers, 0.301, that's my lower number, my upper number, 0, 3.01, hit enter, there it is. Alright, less than 1.3 or 1.13. Alright, negative 999 because my shading starts on the left side, comma, 1.13, and then there's that probability. Alright, between those two, again, the same thing. This is my lower number, this is my upper number, there's my area. Alright, greater than this, 0.59 is where I start, all the way up to comma 99999 is where it ends. So remember, 99999 for the right edge, negative 99999 for the left edge, and you got this normal CDF feature down. Alright, and then percentiles and going the other way. If I know the area to the left, what do I do to find the z-score that's underneath it? Well, we use what's called the inverse normal. So the inverse normal will take in area to the left and it'll return the z-score that has that area to the left. So if I'm looking at this problem, the area to the left of this z-score we're looking for is 0.96. So I call the inverse normal, right, that's below normal CDF, and I tell it the area to the left is 0.96, and it gives me this z-score. Alright, to 2 decimal places that would be 1.75. So that's where that's coming from. Alright, now this is notation that you need to kind of get used to. This is what we call a critical number, a critical value. And it cuts off the upper 3%, whatever this number right here is, it cuts off the upper 3% from the lower 97%. Okay, But it's always that this area that it gives right here is the area to the right, not to the left. Alright, so 0.03 is up in the upper tail. Z 0.03 is what we're looking for. That means that 0.97 is in the left tail, or the left end of this distribution. So that's the number that goes in the inverse normal. Okay, the upper number, the area to the right, is not what the inverse normal wants to take in. It wants to take in area to the left. So we put in the area to the left. 1 minus 0.03 is 0.97. Remember, the total area is 1. So 1 minus this gives us the area to the left, and that gives me that 1.88 number that I'm getting there. Alright, now if you had put in inverse normal, if you'd put in the area to the right by accident, if you put just whatever this number is down here and hit enter, it's going to give you the opposite, again because of the symmetry at 0. So you want to make sure that you subtract that from 1, or you're going to get the wrong end of the bell curve.